Hey guys, Dr. Brown here. Tonight we're discussing area, but we're looking at sine and cosine functions. You may think there's not any organization to some of my videos, and maybe there's not, but the reason for the video would be some kids or students that I've ran into at the mall when I'm sitting around working some math problems, or those that come out to the Kubo and study with me. There's certain aspects that I want to clear up for them. So they had some concerns about sine functions and cosine functions. So bear with me as we walk through this, and then we'll work an area problem using what we've learned. Back in the day, calculators were new, I guess, at that time. They almost needed a car battery to run them. But we were taught, let's say I have a straight line and we're thinking about this line. We're going to divide it into different sections, but different degrees, or radians. We have 0. We're going to divide it into 4 sections, okay, in a marker that evidently has just ran out. How about that? All right, let's try this one. Okay, 0, if you think about a circle, okay, if I divide that circle in half, we're at 0 degrees, and then we start around that circle, it's 2 pi if I go all the way around, 2 pi radians. Okay, well, if I go halfway around, 2 pi divided by 2 is pi. If I break that in half, that's pi over 2. If I break it into 4 pieces, 1, 2, 3, 4, well, now it's pi over 4. 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which 4 over 4 is 1, so that's pi. You can just keep going right around like that. Now here we are at 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4. So you could go around, and now we're back to 8 pi over 4, which is 2 pi, or back to 0. So having said that, now let's think about sine and cosine waves. They're 90 degrees out of phase. If I have a cosine wave, here we are at 1, that's at 0, and it would have that amplitude. We'll just say it's at 1. Well, if I go if I go all the way around to here, I've just gone pi distance. If I go all the way back around, I've gone 2 pi. Back to where I started, that would be 2 pi. So sine wave, it's out of phase with the cosine wave. So let's break those down. This point right here is pi over 4. Now we're breaking this pi, this is pi right here. So we're pi over 4. Here we are at 2 pi over 4, which is really here. 2 pi over 4, which is what? Pi over 2. 3 pi over 4. 4 pi over 4. 5 pi over 4. Now you can see those two curves intersect at pi over 4 and 5 pi over 4. Now you might think, well, how do you know that? Okay, let's think about that. We have an area problem. Of course, all of this surrounds that problem. What's the area bound by y equals sine x and y equals cosine x? Now those curves, as they go up and down forever, there's a lot of different areas that intersect. Well, we're going to look at those at these 2 points. Well, if I set sine x equals cosine x, and we're trying to understand where those intersect, if I divide both sides by cosine x, Sine over cosine is what? It's tangent. Okay, that's tangent x equals cosine divided by cosine equals 1. Okay, if I have a unit circle, here we are with some angle. Okay, so that's my x value right to here, and that's my y value up to there. What do we know about that? Well, x, if it's a unit circle, we know that hypotenuse is 1. X squared plus y squared equals 1 squared. Well, 1 squared is just 1. And what is tangent of an angle? Well, if it's this angle, theta we'll call it here, it's the opposite over adjacent. So y over x. Well, if y divided by x equals 1, y equals x. So y equals x. Well, I can substitute then. I'll just substitute y in, for example. Y squared, because y equals x, plus y squared equals 1. What is that? That's 2y squared equals 1. So y squared equals 1/2. Let's get up here where we can see y squared equals 1/2. Well, if I take the square root of both sides, I have y equals 1 over square root of 2. I know pure math people are falling on their pencil, but I'm going to leave that radical in the denominator. Don't freak out. Why am I doing that? We had to learn two triangles, and well, we've learned many, but two in particular. If I have theta, and theta is pi over 4. Now we had pi over 4. What is that? Well, if this is 180 and I divide 180 by 4, pi over 4 is 45 degrees. Commit that to memory. Pi over 2 is 90 degrees. 3 pi over 4 is 135 degrees, which is just 3 times 45, basically. 1, 2, 3. Okay, and 4 times 45 would give me 180 degrees. So pi over 4, that triangle was 1 square root 2. So if somebody said, what's the cosine of pi over 4 or the cosine of 45 degrees? It's 1 divided by square root of 2. So cosine of theta is 1 over square root 2. Take 1 divided by square root of 2 into your calculator and see what you get. You'll get 0.707, some other numbers. Okay, what's the sine of 45 degrees? Sine of 45 degrees is the opposite over hypotenuse. So the sine of 45 degrees, sine of pi over 4, I should have said that here. Sine of pi over 4 is 1 opposite over hypotenuse, 1 over square root 2. Now that's how I know those two waveforms intersect at pi over 4. And it's also how I know they intersect out here at 5 pi over 4. Okay? As an electrical engineer, we dealt with this all the time. Okay, having said all of that, the other triangle, I forgot to mention, that you need to commit to memory. If I have the unit circle, okay, and I break it into 6. 1, 2, 3, 4, 5, 6. Pi divided by 6. If I take 180 degrees and divide it by 6, what do I get? 30 degrees. So pi over 6 is 30 degrees. So 30, 60, so pi over 6, I'll put it out here, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Now obviously you can reduce those. 3 pi over 6, pi over 2, which is 90 degrees. Pi over 3 is 60 degrees. So that's the triangle you want to remember. Here's a 30 degree. So that's pi over 6. This is 60. This is 90. So 60 degrees is pi over 3. So that triangle, I want you to remember, is 1 square root 3, 2. So it's a 30, 60, 90, but it's 1 square root 3 over 2. What's the sine of 30 degrees? 1/2. What's the cosine of 30 degrees? Square root of 3 over 2, which is 0.866. So these two things, two triangles, you need to commit to memory. Now from that, you don't have to memorize that unit circle that's in the back or front of every math book, and it has all these angles. Okay, certain things to remember might be in this all students take calculus. Just remember that all students take calculus. All cosine, sine, everything in tangents are all positive in that quadrant. Sine is positive here, tangents are positive there, cosines are positive here. Now you might say, well, why? Why is that? Well, okay, let's say we have an angle here. This angle, just like we had earlier, it has a positive x, a positive y. And it's, so if I have a tangent of that angle, it's this positive number divided by that positive number. It gives me a positive number. Cosine, this positive x divided by the hypotenuse. If I have a sine, it's the positive direction here divided by the hypotenuse. So all of them there. What about in this one? It says the sine is positive. So I have this angle right here. Call it theta. The x is negative. So I have cosine of something. I have a negative over a hypotenuse. So it's a negative number. Now sine is a positive y divided by hypotenuse. Okay. Let's practice something here. We have this unit circle here, and we're trying to understand this point, and this is 30 degrees. So we know that 30 degrees is pi over 6, right? Okay, because pi divided by 30 degrees gives me pi over 6. Well, what's that point out here? 30 degrees. Okay, 30 degrees. Cosine of 30 degrees is, which would be my x value, is square root 3 over 2. Square root 3 over 2, comma, sine 1/2. Just work your way around, and that's that point. Square root 3, 2, 1/2. And work your way around. Obviously, all students take calculus, and you can get whether that is positive or negative as you work yourself around with the x and y's. You don't have to memorize this thing just by knowing these two triangles. Okay. All right, having said that, out of all of that, these two curves intersect at pi over 4 and 5 pi over 4. So if we're looking for the area between those two curves, remember f of x, we're going to integrate this on dx, I believe. That means f of x, we're trying to let the actual y value that's larger be the f of x, you know, the integral. Now it may be off the screen here a little bit. That's probably a good thing. All right, so the area then is going to be some limits, a to b of f of x minus g of x dx. Okay, and since we're looking for integrating on dx, we're looking for the y value that's larger, and we're going to make that the f of x, and then the one that's smaller is going to be g of x. Well, if we take an x value and we go up, well, it's obvious this one is larger than that one at that x value. So we're going to let sine theta, or sine x we'll call it, our area then is the integral from pi over 4 up to 5 pi over 4 of sine x minus cosine x dx. Okay, so our area, what's the derivative of sine is cosine, so the integral is minus cosine x minus, now the derivative of cosine is minus sine, the integral is positive sine, so that would be our integration, and we're going to look at this from pi over 4 to 5 pi over 4. All right. Let me pause just for a moment. All right, I'm back. Okay, we had the area equals minus cosine x minus sine x from 5 pi over 4 to pi over 4. So I've cleaned up the board and have redrawn our circle, and I have a pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. Okay, we're integrating that from pi over 4 to 5 pi over 4. So let's plug in our 5 pi over 4. What is the cosine of 5 pi over 4? Now you know, since this is pi over 4, we have a 45-degree angle. But that 45 degrees now is just below horizontal. And remember, we said all students take calculus, so I know my cosine is negative here, and it just makes sense. I have now my 1 square root 2, that's my 45 degrees. So if that's my axis, my x is negative. So what is cosine of that angle? It's the adjacent divided by the hypotenuse, and which is 5 pi over 4 is minus 1 over square root 2. So I have a negative already, and a negative 1 over square root 2 minus the sine of 5 pi over 4. Well, the sine of 5 pi over 4, it's negative also. It's a negative 1 because it's headed down, and this is my x-axis here, and that's my y-axis coming through. So it's negative 1 over square root of 2. Well, it's minus this minus 1 square root 2. Okay, now all of that's subtracted from we're back to putting in pi over 4. So pi over 4 is here. All students take calculus. Everything is positive there. I have a positive x and a positive y. Okay, so I have this angle right here. So I have 1 square root 2. Okay, what is cosine? It's 1 square root 2, but I have a negative there, so negative 1 square root 2 minus sine, which is 1 square root 2. Okay, what do we have here? Negative, negative is a positive. 1 square root 2 minus minus is positive. So I'm adding those together, so I have 2 square root 2 minus, so a negative minus a positive plus a negative, so it's minus 2 square root 2. So now a negative and a negative, I add those together, so 2 square root 2 plus 2 square root 2 is 4, over square root 2. Now then, I'll make the math people in the world happy, okay? I'll multiply this by square root of 2 over square root of 2, and that gives me 4 square root 2 over 2, which is 2 square root 2. So the area of sine x minus cosine x, integrating that from the intersection of those two curves, which would be pi over 4 to 5 pi over 4, that area is 2 square root 2. Okay guys, why are we doing this? Together we're trying to build a better tomorrow and do that through math. Keep studying. Keep working problems like this with sines and cosines, tangents, as many as you can get. And my old calculus book has plenty, okay? All right, that's all for now. We'll talk to you next time. Thanks.